Next, we're going to learn about scatter plots. A scatter plot is when you create a graph that shows how two sets of data are related. Most scatter plots will show some sort of correlation or relationship between the two data values. If the correlation is positive, it will look like the graph is going up as you read it from left to right. One example of a positive correlation is the older you get, the bigger your shoes, up to a certain point. There could also be a negative correlation, which will look like a graph going down as you read it from left to right. An example of negative correlation is your heating bill will go down as the temperature outside goes up. There is a potential that there will be no relationship between the data, and that will just look like random points scattered all over the graph. For most scatter plots, it's helpful to draw a line of fit when there does seem to be some correlation between the data. The line of fit goes through the center of the data as close as you can, and it's used to predict values as the data would continue. Finally, we'll talk about causation. Causation is when one of the data values changes the other data value. An example is the more you work, the more you earn. That's a causal relationship. Sometimes data are related for no apparent reason, and you cannot imply that there is a causal relationship between the two. Starting off, we're just going to determine whether or not the scatter plot has any sort of correlation. Our first scatter plot is showing us the amount of study time on the x-axis and the test score that the student earned on the y-axis. It appears that the relationship is positive. We could put a line through the center of the data, and it is going up as we read the graph left to right. So this has a positive correlation. The second part is we need to interpret the correlation using the data values. Basically, this boils down to the more you study, the better your test score. Our next graph is showing us number of siblings versus GPA. As we can see, this data is all over the place. There is absolutely no relationship between how many siblings you have and how well you do in school. Our last graph is showing us how long we've been on a medicine versus the symptoms of our illness. This graph is decreasing from left to right, so there is a negative relationship. Or a negative correlation. And as we were saying, the longer you're on the medicine, the better you feel. Our next job is to create a line of fit, write an equation for it, and use that equation to make some predictions. Our scatter plot is showing year past 2000. Typically, when you're talking about years, it'll give some sort of starting year, and they'll call it year zero, because using the year 2000 or the value 2000 tends to make numbers pretty big and not quite as easy to work with. So we're calling year 2000 year zero, and year 12 is 2012. We can see the population of Cottage Grove growing slightly each year. So there's a positive correlation between time after 2000 and population of Cottage Grove. Our first job is to draw a line of fit through the data. I'm going to try and eyeball a line right through the center of the data, and I may make some adjustments based on where it fell. Looking at my first line, I want to see how well it fits the center of the data. You'll take a look at how many data values fall below and above your line and how far away from your line they are. First of all, based on just numbers, I have 1, 2, 3, 4, 5, 6 data values below my line and 1, 2, 3, 4, 5 data values above my line. So it seems like I did a pretty good job the first time around. It looks like there's one data value right on my line, or maybe slightly above. Also, the spacing of those data values to the line seems to be pretty equal as well. There are some that are pretty close to the line and some that aren't. My line does seem just a little high to me, so I'm going to adjust it downward just slightly to try and give it a better fit. This looks like an almost perfect line of fit right through the center of the data. Next, we're going to write an equation for our line of fit. To do that, you want to pick two values that are on the line. They do not necessarily need to be scatterplot data values. You can also use your two number lines or your axes to pick a data value that is on the line. The first data value I noticed that appears to be on the line is 133. And I also noticed the data value of 434. We'll use these two to write the equation of the line. First, we'll need our slope. Slope is change in y over change in x. I will subtract my y values in the numerator and subtract my x values in the denominator. This gives me 1 over 3 for my slope. Once we have our slope, we can use point-slope form to finish writing the equation of our line. We need an ordered pair. We have two of them, we'll choose one, and the slope, which we just found. Substituting in our slope, I'm going to use 133 for my ordered pair, so I'll subtract the 1. If you had me try 2, you may remember the asylum analogy. We also talked about it when we saw quadratic functions. In vertex form, if it's going inside the parentheses grouped with the x, it doesn't act normal. So our ordered pair is a positive 1. We put it into the equation as a negative 1. Outside the asylum is normal. That y value will stay a positive 33. To get this into slope-intercept form, we will distribute our slope of 1/3, multiplying it by the x and multiplying it by our negative 1. 33 minus 1/3 is 32 and 1/3. Next, I want to tell you how to interpret your equation. The slope is the rate of change. We can think about the units that were on each of our values as we found the slope. Our numerator was change in population, or people, and our denominator was change in year, the x value. What our slope is telling us is that the population changes by about 1/3 of 1,000, because when you look at the y-axis in our graph, it says population in thousands, so it's not 1/3 of a person, it's 1/3 of 1,000, or about 300 people per year. The y-intercept gives us our starting value. Remember, we called 2000 year 0. So this says that in the year 2000, there were about 32,300 people living in Cottage Grove. These are both approximations and not exact values. They're based solely on our line of fit. And as you can see, not all of the data values fit perfectly on our line of fit. Finally, we will use our equation to predict how many people might be living in Cottage Grove in the year 2025. That is 25 years after 2000, so that is our x value. A third of 25, 3 goes into 25 8 whole times with 1 left over. When we add 32 and 8, we get 40, and 1/3 plus 1/3 is 2/3. It does not make sense to talk about 40 and 2/3 thousands people in Cottage Grove, so we'll convert this to actual people. 2/3 is about 667 people, so 40,667 people living in Cottage Grove in 2025 based on our line of fit and the data that we have from 2000 to 2012. Our last topic is causation. Does one event cause another event to happen? We can think about this like we thought about probability with dependent events. one event change the probability of the next event. Sometimes they were independent events and they didn't have any impact on one another. That would be a case of no causation. First of all, we're going to determine if the relationship is positive, negative, or there's no correlation, and then we'll talk about whether or not the relationship might be causal as well. Taking a look at a sandwich shop, the amount of turkey sold versus the amount of ham sold. I would guess this would be a negative correlation because if you're buying a turkey sandwich, you are probably not buying a ham sandwich. I would also say that this might be a causal relationship for the same reason. Our next one we might need to think about a little bit carefully. A car's speed, how fast the car is going, and its stopping distance, which is how long it takes the car to stop. This would be a positive correlation. The faster the car is going, the longer it will take the car to stop. This is a causal relationship as well, for the same reason. Finally, our GPA and the amount of TV watched per week. As the GPA goes up, the amount of TV watched probably goes down. I would say this is a negative correlation. However, it's probably not necessarily causal. Your GPA doesn't go up because you stop watching TV. Your GPA goes up because you are studying. There's a third factor that causes both of these two. As you're spending time studying, you are not spending time watching TV. Finally, I have some you-try problems for you. Please come to class with these prepared so we can start our time well together. Questions 2 and 3 also relate to the scatter plot.